All right, the last thing we're going to talk about in this unit, and this kind of relates a little bit more to with molarity, but we're going to be looking at diluting solutions. Dilutions is basically a method to convert solutions with high concentrations to a lower concentration. And what I want you to think about is making some lemonade, right? Especially making it from scratch, not a mix. When you make lemonade from scratch, you put in your lemon, your water, your sugar, whatever else you want to flavor it. And when you taste it, and it's so sour and strong, it makes your whole face like spasm. What you're really kind of interpreting there is that you have a very high concentration of lemon. So what do you do to it? You don't throw it out, you don't start over, you don't add more sugar because that really wouldn't help. You add more water. You make the solution a lot more dilute so that when you take that same amount of lemonade out as you did before, there's less lemon involved, and so it tastes a whole lot better. And so often in chemistry, we will dilute a more concentrated solution, something that has a high molarity, to a less concentrated solution, a lower molarity. Now, how do we do this? We take a small amount of the concentrated solution and add water to it. Now, there's a very easy mathematical way to figure out how you can do this. We use this formula, M1 V1 equals M2 V2. M1 is the molarity of the what I call the before quote unquote solution. So that's the more concentrated thing. V1 is the volume used of the before solution. So how much of that are we going to take out and make more dilute? And M2 is the molarity of the quote unquote after solution. So after you add all of your water, this is the new concentration. It's going to be lower than what you started with. And V2 is the volume of that new after solution. Now, this doesn't work only just for molarity. You can use this with any concentration units. So like we were talking about percent mass by mass or percent volume, we can use those. You can even use parts per million, parts per billion, any type of concentration unit, and the formula is exactly the same. I just put C there for concentration. Here's the catch, okay? Your units must cancel out properly. So I can't have units of milliliters on one side and units of liters on the other side. I can't have one form of concentration like molarity on one side and then percent volume on the other side. They all have to be the same units so that they cancel out properly. And the same thing is true for using molarity. Okay, my volumes can't be in different units. I can't have cubic centimeters for one and liters for the other. So they all have to be the same units. So let's do a quick practice problem. How do I make 3 liters of a 2.0 molar HCl solution from 12 molar HCl? So basically, I'm starting with this really concentrated solution of HCl. I need to take a little bit out of it and dilute it to a total of 3 liters with the goal of getting down to a molarity of 2 molar. So let's label our things here for our equation. This is our before solution. So that's M1. Actually, I'll use the same colors as I did up here. And then we want to make 3 liters, that's our after solution, with a concentration of 2 molar. There's M2. So naturally, if you were like wondering, well, what do I have to find? I have to find out how much of that original concentrated solution I need to use. All right, so let's take everything and plug it into our dilution formula. So I'm starting with M1 V1 equals M2 V2. M1 is 12 molar. I'm going to solve for V1. M2 is 2 molar. And V2 is 3 liters. So I'm going to solve for V1. And again, units are important because notice here my M's cancel out and I'm just left with liters. So put that into my calculator, keep track of sig figs. The answer comes out to 0.50 liters. Now, notice the question here was like saying, how do I make this solution? So what this tells me that I need to take half a liter of the 12 molar HCl solution and add enough water to make 3 liters of that solution. And if I do that properly, I take out half a liter, put it in another container, and then I dilute that container to a total of 3 liters. That will make a 2 molar solution of HCl. All right, so let's get some more practice with this. So if 0.850 liters of a 5 molar solution of copper nitrate is diluted to a total volume of 1.80 liters by the addition of water, what is the molarity of the diluted solution? So first things first, let's just label all of these. We know we're going to be using our dilution formula here. So let's label everything. So where's our before solution? That's right here. This is M1 and this is V1. And we're diluting it to a volume of 1.8 liters. That's V2. And the problem is asking us to calculate M2. All right, what I'm going to do is kind of take a close look and make sure that all my units match up. So my units of volume are the same, they're liters, and it's okay that concentration is in molarity. So plug everything in. So M1 is 5 liters, V1 0.850 liters, M2 is what I'm going to find, and V2 is 1.80 liters. So I solve for M2. Notice my, oops, I messed up with my units. That should be molar. Notice liters cancel out, leaving molar there. And so M2 comes out to 2.36 molar. Now, again, like I've told you in the past, you must be able to show your work, okay, and not scattered all around. I want to see it nice and organized. What formula are you using? Are you putting the numbers in correctly? Because if you get an answer wrong, but your work looks correct, maybe you just plugged something wrong in your calculator, I want to give you as many points as I can. But if your work is scattered all over the place, that I can't tell what you were trying to do, then you're going to get very little, if any, credit when your answer is wrong. So make sure that you show all of your work clearly and neatly. All right, and then finally, what volume in milliliters of 0.12 molar HBr can be prepared from 11 milliliters of 0.45 molar HBr? Okay, so let's just try to identify what everything is here. Okay. First of all, what is our before solution? Like, what's the higher concentrated solution? Well, that's this one here. And we are taking 11 milliliters of it, so that's our before volume. And we're getting to 0.12 molar. Now, the way I know that that has to be M2 is because it's a lower concentration. Dilutions, just by virtue of the name, always go from high concentration to lower concentration. And so we're going to solve for V2. Now, one of the things that you need to, again, check yourself on are the units. Are my units okay? Well, for concentration, units of volume, I should say, must be in liters. So before I can plug anything in, I need to deal with that V1. So I'm going to do a quick conversion. There's 1,000 milliliters in 1 liter. And so now I'm converting that into liters. Now there's the V1 I'm going to put in. So M1 is 0.45 molar. V1 is 11 milliliters. M2 is 0.12 molar. And I'm solving for V2. So I solve for V2. And the units of molarity cancel out. Oop, I used the wrong number. 0.011 liters. And that comes out to 0.041 liters. I'm not quite done yet. If you stopped here on on an assessment, you probably would get like, maybe half a point taken off because the problem tells you the volume needs to be in milliliters. So we're going to do one final conversion. There's 1,000 milliliters in 1 liter. And so my volume that I can dilute to is 41 milliliters.